is 12:15, and this is rotation 1. And so we are going to measure how much dissolved oxygen there is in the water. This is my molecular model of water. These are the water molecules, H2O, 2 hydrogen and 1 oxygen, and then these are the O2s, the oxygens. And so this is what we're going to look for. We want to know how many oxygen molecules there are in a million molecules of water. Okay, so first I need a volunteer to go get the sample. Okay, Luis, you were quick and quiet. All right, because we're testing oxygen in the water and not the air, you're going to put the bottle under the water and the cap, kind of jiggle it, make sure all the bubbles go up, and then cap it under the water. Test to make sure there's no air bubbles in it, okay? Yeah. And the easy place to get is down there on the bridge. All right, Elizabeth, would you go down and take the water temperature, please? Okay, so the temperature is 17. So just over here next to rotation, right, 17 degrees.
Right here?
Yeah. That's Celsius.
What about here?
Nope, that's something else. Now everybody put goggles on. Richie, you're ready, so we'll let you start. Can you see the oxygen?
No.
So we're going to add some chemicals so we can. And the first chemical we're going to add is manganese sulfate. All right, you're gonna this afternoon you're going to be doing lots of dropping. If you hold the bottle straight up and down, then each drop is the same size, and all these tests have been calibrated for that. Okay, so Richie, come on over and do 8 drops into the bottle. And what the manganese is going to combine with the oxygen molecules.
Iodine has replaced the oxygen molecule. 7, 8.
All right. Now, can you see?
Yeah.
Can you see a change?
Yeah.
It's
really.
Kind of like
A little bit.
it's kind of like a darker color.
Yeah,
At
but
the top.
Swirbling.
all right. Taryn, 8 drops of alkali potassium iodide. Now, this is going to combine with the manganese, and you might not have 8 drops in that bottle.
Whoa.
Whoa.
We have iodine in here, and here's an 8.
Did you have 8? Wow.
Yep.
Amazing. All right.
Whoa.
So now, what about the last drop?
No, there were 2 drops. 1, 2, and 1, 2.
Oh,
I said 8.
okay.
Wait, am I supposed to have blue?
Yeah, I'll give you one up here just a second. So,
Whoa, it's hot.
so now we're going to mix it, Callie, slowly like this. Mix it till you to stop.
Cali style.
And what we've done,
So then are the little flakes the oxygen?
yeah, can you see it now?
Right.
Because what we've done is the manganese joined the oxygen, the alkali potassium iodide joined the manganese. Okay, so now, yeah, we have 2 molecules attached to the oxygens. And we can stop. So now they're heavier and it formed a precipitate. We have 2 more molecules attached to the
The water
oxygen
looks thicker
than it did before. Well, because you can see it. Okay, now here's a question. If at this point the oxygen, this was clear, what would that tell us about how much oxygen is in the sample?
None.
Why?
Because when the 2 chemicals mixed together, it made the oxygen heavier, so it turned white. But if you
Yeah, it
could,
turned
but if there
gold.
were no white specks, then you'd be able to see.
You're right. If it didn't turn gold, then that reaction wouldn't have been able to happen if there was no oxygen, so it would have stayed
And it
clear.
didn't have any oxygen to tell them to put it under the water.
But it does, because we have it. Okay, so now we want to dissolve that precipitate.
Whoa.
And Sue, who hasn't had a turn yet?
You have had it.
You got to mix
I
it.
have to mix it.
Okay,
That's a
so Kayla, you're going to add 8 drops of the acid. Richie, you want to scoot back so she can get over here a little more? That will eat holes in your clothes, so
Spill it all over yourself.
Sounds
we want to
painful.
keep it on the,
Will it eat holes in your skin?
it'll burn it like a sunburn.
Oh. And that's why we wear gloves.
That's right, and golf.
I don't have gloves.
1, 2, 3. All right, and
Ellie.
Luis, will you just slowly mix it and see how it's turning brown? It will eventually dissolve all that. The rest of you can take your gloves. Oh wait, okay. So whenever you put gloves on, it could be because you're going to paint and you don't want paint on your hands. You're working on your car and you don't want your hands to get greasy. You're doing first aid and you don't want somebody else's blood and guts on your hands, or you're working with chemicals. For whatever reason you put gloves on to keep your hands clean, the way to take them off is you take it and you turn it inside out, put that one inside that glove, turn it inside out, and you've never touched whatever yucky thing was that you were avoiding touching. And then, except for Luis, who needs to have his goggles on, the rest of you could put them on top of your heads or wear them like a necklace. Okay. How does the oxygen get in the water? Anybody have a good guess?
Chemicals? The plants?
Why?
Because the plants breathe it. Because they breathe in carbon dioxide and then they breathe out the oxygen, so the oxygen stays in the water.
Right. And what process do plants have that? Yes, photosynthesis. What is the energy driver of photosynthesis? The sun.
Sunlight and water can too.
Water can drive photosynthesis?
I guess that's what
That's what
our notes had. So Mr. Holland told us to write down with the sun or the water.
How does the water drive photosynthesis?
He never told us. He just said.
Okay, well let's think about the sun.
No, I think what he meant was that the sun would reflect the water and the water would get in the plant if it was an underwater plant.
Well, the sun shines down on the water and hits the water plant. Okay, so it's 5 o'clock in the morning, and plants have sat there all night, no sun. They're cold. And it's cold. Yeah, the temperature's cold. Do you think you'll have more oxygen then or at 10 o'clock in the morning after the sun's been up for a few hours?
10 o'clock.
Why, Elizabeth?
Because the sun's like.
Not because it's hot. Not because it's hot. What is the sun doing to the plants?
It's giving them.
The photosynthesis, and you will actually get to see that with this test.
Kind of like
when you look at everybody's data from this morning and this afternoon, the first group will have kind of low DO because it hasn't been on the sun hasn't been on the water. But then as the day goes by, you get more oxygen, and then towards the afternoon, like the last groups today, it'll go down again because another factor of oxygen is temperature. When the molecules when the water's warm, they move fast and they bump each other. And so they'll bump each other around, and there won't be as much space for the oxygen to be there because they'll get bumped out. If it's cold, they don't move as fast, and so there'll be more room for more oxygen to fit in. So in the morning, the water's colder, has more potential to hold oxygen, but the sun hasn't been shining all night, and so the plants haven't been photosynthesizing. So that's why you get like from 10 to maybe 12 or 1, you'll have a lot of oxygen, and then later, as we get later, we get less oxygen because the water starts warming up. All right, another way oxygen gets into the water is through turbulence. The wind whipping it, especially if it's really windy and makes waves on a lake or something, that will add oxygen, or when it comes over a waterfall or over rocks, that's taking oxygen from the air and mixing it into the water. So the two ways oxygen gets into the water is through the aquatic plants or through turbulence. Okay, so now, here's the test. How does water temperature affect how much oxygen the water can hold?
because if colder, it has more space.
And therefore it can...
More room for oxygen.
Yeah, okay, so if you put water temperature, cold water holds more. How's that looking?
Smaller.
It's smaller, it's still not dissolving very fast. I bet it's because this bad chemicals by now. Okay, how does aquatic plants affect the amount of oxygen? You don't have to have the goggles on your eyes anymore. Oh, and Luis, you can give me yours too. Yes, Callie.
Because when
No,
the
no,
plants,
your gloves. Give me your gloves.
when the plants breathe in the carbon dioxide and they let go of the oxygen, and the water gets more oxygen in it.
Yes. Keep your goggles on your head because you'll wear those all through all the chemical tests. Okay, so say it again, Kelly. What do plants do?
They breathe in the carbon dioxide and then they breathe out the oxygen, so the water has more oxygen.
Right, so you can say they breathe oxygen into the water because you don't have a lot of space to breathe. And water turbulence.
Because the wind has oxygen going through it, so
Well, it's just the oxygen that's in the air from these trees. So that one is when water turbulence adds oxygen to.
fish.
I kind
Okay,
of
what's
fish.
a cold water fish?
Oh, a trout?
Yes, all trout are cold water. Why do we call them cold water trout?
Because they only live in cold water.
And why do you think they want to live in cold water?
Because there's more space.
There's more
More
oxygen.
space, which means there's more oxygen.
Yeah. There's more oxygen in cold water. Okay, what's a warm water fish?
I know them, but I don't remember the name.
Mosquito fish?
What?
Mosquito fish?
Yeah, mosquito fish can live in warm water.
I
Bass,
used to have mosquito fish.
bass, carp, pupfish, perch. Those are all. Did I say catfish? They live in warm water. They can take tolerate lot less oxygen.